Hi friend, welcome to Math A to Z. And the topic of this class is comparison test, limit form. This belongs to the convergence of infinite series of real number, and the comparison test limit form state that let un, this is an infinite series, and vn, summation vn, this is also an infinite series, be two infinite series of positive real number. This is important, positive real number, such that limit n tends to infinity even by vn equal to L, where L 0 less than less infinity. That is, L is finite. L is finite. Then this test, comparison test of limit form, conclude that summation un and summation vn both convergent or divergent together. If summation un is convergent, then vn is convergent. Also, conversely, vn is convergent, then un is convergent. And similarly for the divergent. Now we go to the proof of this test. Proof. Here, limit n tends to infinity un by vn equal to L, where L equal to finite. So from the definition of the converging sequence or convergence of a sequence, there exists m belongs to capital N. Obviously for pre-assign epsilon greater than 0. Pre-assign epsilon greater than 0, there exists m belongs to capital N such that mod un by vn minus L less than epsilon for all n greater than equal to n. And from this result we get L minus epsilon less than un by vn less than L plus epsilon for all n greater than equal to n. Now L minus epsilon into vn less than un less than L plus epsilon into vn for all n greater than equal to n. Okay. Now we take the second and third relation. Un less than L plus epsilon into vn. Here L plus epsilon is fixed, so it can be assumed as a constant k. Constant, that is un less than k into vn. Now from the comparison test in general form, which is discussed in previous classes, we know that if summation vn is convergent, then if summation vn is convergent, then summation un is also convergent. Also, it states that if summation un, this series, is divergent, then summation Vn is also divergent. Okay, from this relation we get these two lines. Now we get the first and the second portion. We get L minus epsilon into Vn less than Un, imply Vn less than 1 by L minus epsilon into Un. Here Vn less than, similarly k dash into Un, where k dash equal to 1 by L minus epsilon is constant. From this relation, by using comparison test in general form, we can write if summation un is convergent, then obviously summation Vn is convergent. And from this relation, we also say that if summation Vn is divergent, summation Vn is divergent, then summation Un is also divergent. Okay. Now these four lines are given from these two relations. The first line and the third line. If we add first line with the third line, then we say that here Vn is convergent. If Vn is convergent, then Un is convergent. And here, if Un is convergent, then Vn is also convergent. So we say that summation Un and summation Vn both convergent together. If one convergent, then another convergent. Okay. Similarly, from second line and fourth line, we get if Un is divergent, then Vn is divergent. And here, if Vn is divergent, then Un is divergent. So, from here, from second and fourth line, we say that summation Un and summation Vn both divergent together. Okay, so we say that summation Un and summation Vn are convergent or divergent together if this limit holds. Okay, this is very easy test, and this is also an important test of convergence of series. Okay, this is the proof of the comparison test limit form. Now we go to some important problem based on this test. First example 1. Now we clean the board. Example 1 plus 2 by 2q plus 1 plus 2 plus 3 by 3q, 1 plus 2 plus 3 plus 4 by 4q plus, this is an infinite series. Here nth term Un 1 plus 2 plus 3 plus n plus 1 by n plus 1 the whole cube, n plus 1 to the power 3. Okay, this is equal to n plus 1 into n plus 1 plus 1 by 2 into 1 by n plus 1 the whole cube, and this gives n plus 2, this and this one is cancelled, by 2 into n plus 1 whole square. Now if we consider Vn equal to 1 by n and limit n tends to infinity, un by Vn equal to limit n tends to infinity, n plus 2 by 2 into n plus 1 whole square into n by 1, and this limit obviously gives half, finite. Okay, so by comparison test of limit form, we say that summation un, this infinite series, and summation vn, that is summation 1 by n, both convergent and divergent, and we know that summation 1 by n is a divergent series. This can be proved by Cauchy's general principle of convergence. We know that summation 1 by n is divergent series. Also, this is P series with P equal to 1. So this is divergent, and hence this test gives this is also divergent. Okay, this is example 1, and we go to another example, example 2. Example 2. Here the series is summation n equal to 1 to infinity cube root of n cube plus 1 minus n. Okay, here un is given cube root of n cube plus 1 minus n, and we multiply denominator and numerator both by n cube plus 1 whole to the power 2 by 3 plus cube root of n cube plus 1 into n plus n square, and here also n cube plus 1 to the power 2 by 3 plus cube root of n cube plus 1 into n plus n square. Here a formula a minus b into a square plus ab plus b square. So this is aq minus bq. aq means nq plus 1 minus bq means nq, by denominator is the same, nq plus 1 whole to the power 2 by 3 plus n into cube root of n cube plus 1 plus n square. So this is 1 by this. Now here we choose Vn equal to 1 by n square. Then limit n tends to infinity, un by Vn equal to limit n tends to infinity, n square by n cube plus 1 to the power 2 third plus n into cube root of n cube plus 1 plus n square. And if we divide numerator and denominator by n square, then we get limit n tends to infinity 1 by, this is 1 plus 1 by n cube whole to the power 2 third plus this is cube root of 1 plus 1 by n cube plus 1, and this limit is obviously 1 third, that is finite. So both series summation un and summation vn are convergent. and we know that summation Vn equal to summation 1 by n square. This is P series with P equal to 2 greater than 1. So this is convergent. So by comparison test of limit form, we say that the given series is also convergent. Okay. Now we go to the third example. And the third example is test the convergence of the series summation sine 1 by n. Here un sine 1 by n, let Vn equal to 1 by n. Now limit n tends to infinity un by Vn equal to limit n tends to infinity sine 1 by n by 1 by n equal to 1, finite. So by comparison test, both the series summation un, that is summation sine 1 by n, this is the given series, and summation Vn, that is this. These two series are converge or diverge together, and we know that this is the divergent series. So from here, and by using comparison test of limit form, we say that this is also divergent series. Okay. Now go to the next example. Example 4. Take the convergence of summation sine q 1 by n. This is very simple example, like as the previous example. If we consider Vn equal to 1 by n, then limit n tends to infinity sine q 1 by n by 1 by n equal to obviously 1 q, that is 1. So finite. And by comparison test of limit form, we say that this is obviously convergent series, because this series is convergent since P equal to 3 greater than 1. This is P series, P greater than 1. And we consider the next example of this class, and this is not belongs to this test. This is belongs to the previous comparison test or comparison test in general form, but this is the important, very important example. Convergence, test the convergence of e to the power minus n square, exponential minus n square. Here, to prove the convergence or divergence, or test the convergence or divergence, we consider the series of e to the power n square. This gives 1 plus n square plus n to the power 4 by factorial 2 plus n to the power 6 by factorial 3 plus this is an infinite series, and we can write e to the power minus n square, e to the power n square greater than n square. Here this term can be deleted, only one term n square. So the right side must be less than the left side, and we get e to the power minus n square obviously less than n square. So if we consider un, and this side is Vn, and here constant k equal to 1. Now the comparison test of in general form, we say that if summation Vn is convergent, then summation un is also convergent, and we know that summation Vn equal to summation 1 by n square. This is P series with P equal to 2, that is P equal to 2, that is greater than 1. So this is convergent, and obviously this series is convergent, that is the given series is convergent. Okay, this is the content of today's class. Thank you for watching. Thank you very much.